Hello everyone, welcome to Audit Analytics. My name is Kelly Duan. For this module, I will introduce you cluster analysis. In this video, we will learn some basic concepts and algorithms of clustering, understand how they work, evaluate the performance of clustering models. Then we will learn how to apply clustering to audit procedures and what kind of tools you can use to perform cluster analysis. Machine learning includes three main types of paradigms. One is unsupervised learning. Usually it deals with unlabeled data. This includes clustering, which divides data into groups based on information found in the dataset that describes the objects and relationships. We'll discuss more about this topic in this module. The second one is a dimensionality reduction. Especially in today's big data environment, dataset with many different features, hundreds or thousands of attributes, tend to have high dimensionality. As the dimensionality increases, the computational complexity increases. It gets harder to analyze the data to gain meaningful information because the dataset contains many noises. Therefore, reduced dimensionality is commonly performed to eliminate irrelevant features, reduce noise, identify the key features that could represent the whole dataset, make the model easier to understand. PCA, Principal Components Analysis, is a common technique to use. Then the next type is supervised learning, usually deals with labeled data, which includes classification, regression. Supervised learning is about there is an input and an output. The task is to learn the mapping from the input to the output, and the correct values are provided by a supervisor. And the next type is called reinforcement learning, which means that the model learns from the data analysis to solve a problem, but the model is not trained with a labeled dataset. So the model is like a decision-making agent. It receives feedback from a set of the trials and errors, learn the best policy, and it's more like a behavior learning model. So now the question is, what is a cluster analysis? So cluster analysis is partitioning objects into groups, what we call the clusters, with similar characteristics. It minimizes the intra-cluster distance, but maximize the intercluster distance. So here is a simplified example. The intra-cluster distance are minimized. Cats are grouped together and the dogs are grouped together. So the intercluster distance are maximized. Clearly, cats and dogs are different clusters. So before we dive into the details, let's take a little test. So in this question, how many clusters do you see? Is it one cluster, 2, 4, 6, or depends on the context? The answer is it depends on the context. So let's see how it works. When we determine the number of clusters, the notion could be ambiguous, as indicated in this slide. The same data distribution could be 2 clusters, or could it be 4 clusters, or 6. So it totally depends on the situation or the context that you are working on. Clustering is a set of clusters. It is a data mining technique. There are various types of clustering approach. The most common discussed among different types of clustering is whether the set of clusters is nested or unnested. This is what we call partitional or hierarchical clustering. Clustering could be partitional, which means that a division data objects into non-overlapping subjects. Clustering can also be hierarchical clustering, which is a set of nested clusters organized as a hierarchical tree. There are also other types of clustering, such as exclusive clusterings. It assigns each object to a single cluster. Non-exclusive clustering. It is objects can simultaneously belong to more than one group. Fuzzy clusterings means every object belongs to every cluster with a membership weight between 0 and 1. 0 means absolutely doesn't belong. 1 means absolutely belongs to that group. Complete clustering assigns every object to a cluster. Partial clustering assigns some objects to a cluster. When clusters are in different sizes, shapes, or densities, the clusterings can be based on similar features of objects or different features. Here is an example of the partitional clustering. As you can see, data objects are divided clearly into different groups without overlapping. Here is an example of the hierarchical clustering. As you can see, the data are separated based on a dendrogram or hierarchical orders. There are also different types of clusters can be formed based on different algorithms. Here is a list, and I will show you some examples what they look like. The first one is well-separated clusters, which is a set of objects that the objects is closer or more similar to every other objects in the same cluster than to any other objects not in the cluster. So which means from this picture, you can clearly see the points are separated. Points within one cluster, let's say in the blue circle, is far away from the other clusters. See the points in red and green. The next type is called center-based cluster, also known as a prototype-based cluster. It's a set of objects that is closer to the center of the cluster or centroid than to the center of any other cluster. For example, the points in the green circle, so the distance from the points in this cluster to the central point of the green circle is closer than the distance of the point to the central of the yellow circle. The next type is called contiguity-based cluster, also known as a graph-based cluster. This type of cluster is a set of points that are closer or similar to one or more other points in the same cluster than the points in other cluster. So you can think of this as a nearest neighbor. The next type is called a density-based cluster, which is based on the density of the points. Separate high-density area from low-density area. We usually use this approach when the dataset contains noises and the clusters are irregular or intertwined. The next cluster type is a conceptual cluster, also known as a shared property cluster, which is a set of objects that share some property. And this is it for this video. We will discuss more about clustering in the next video. Thank you for watching. Hello everyone, this is Kelly. Welcome back. Let's continue our discussion about cluster analysis. In this video, we will cover some of the clustering algorithms. We will mainly discuss three types of clustering algorithms: k-means, hierarchical clustering, and density-based clustering. These three are commonly used during cluster analysis. First, let's talk about k-means. K-means is a prototype-based partitional clustering approach that attempts to find a user-specified number of clusters, which are represented by their centroids. To use a clustering k-means algorithms, first, users need to select k points as the initial centroids, then form k clusters by assigning all points to the closest centroid. This step is performed multiple times until the centroids don't change. So in this example, points are assigned to the initial centroids. We use the mean as the centroid point after the points are assigned to a closest centroid. So the centroid is then updated. Then reassign the points to the closest cluster center, and so on. And we iterate the steps multiple times until no points are shifting from one cluster to another. The centroids don't change that much anymore, so in this case, you can clearly see three clusters are formed. Here, you can clearly see the cluster formation based on different central points. K-means is simple and can be used for a wide variety of data types. It's quite efficient, less susceptible to initialization problems. However, its variations have a number of limitations with respect to finding different types of clusters. So k-means is not suitable for all types of data. It can handle clusters of different sizes and densities or non-globular clusters. And k-means has trouble clustering data that contains outliers. But sometimes outlier detections and removal can help significantly in such a situation. And k-means is also restricted to data for which there is a notion of a center. Since k-means has a problem handling data with different sizes, in this case, k-means cannot find three neutral clusters because one of the cluster is much larger than the other two. In this case, the larger cluster can be broken down, while one of the smaller cluster is combined with a portion of the larger clusters. So one solution to this is to use many clusters, break down the data set to many different clusters. Another limitation of k-means is difference in density. So k-means fails to find three natural clusters in this picture because the two smaller clusters are much denser than the larger one. The potential solution is to assign many clusters in this case. In addition, k-means cannot handle non-globular shapes. K-means finds two clusters in this case that makes portions of the two natural clusters because the shape of the natural cluster is not globular. To overcome this limitation we just mentioned, one solution is to use many different clusters and find the parts of the clusters. Now after that, put all the clusters together. The next algorithm we will cover is called hierarchical clustering. Hierarchical clustering refers to a collection of closely related clustering techniques that produce a hierarchical clustering by starting with each point as a single cluster and then repeatedly merging the two closest clusters until a single cluster remains. Hierarchical clustering is often displayed graphically using a tree-like diagram known as dendrogram, also shown in the slides on the left. Clusters can also be displayed as a nested cluster diagram, which is shown as on the right in the slides. There are two main types of hierarchical clustering. Agglomerative clustering, the most commonly used. It starts with the points as individual clusters, and at each step, merge the closest pair of clusters. Divisive hierarchical clustering. It starts with one all-inclusive cluster. Then, at each step, split or cluster until only one single cluster of individual points remain. Traditionally, the algorithms use a similarity or distance matrix, such as Euclidean distance, to determine the merge or split of a cluster. Hierarchical clustering makes good local decisions about combining two clusters. However, once a decision is made to merge two clusters, it can now be undone at a later point, and the clusters at each level do not represent local minima with respect to the total sum squared error. Hierarchical clustering algorithms are expensive in terms of computational power requirement and storage requirement. Also, all merges are final may be a problem for noisy and high-dimensional data with a different size and shape. In this case, we can consider to use the technique partitional clustering, such as k-means, create many small clusters, then perform hierarchical clustering using these small clusters. Now the next algorithm we are going to discuss is the density-based clustering. Density-based clustering is a partitional clustering in which the number of clusters is automatically determined by the algorithm. Points in low-density regions are classified as noise or omitted. Therefore, density-based clustering does not produce a complete clustering. The most popular density-based clustering algorithm is dbScan. In the center-based approach, density is estimated for a particular point in the dataset by counting the number of points within a specified radius of that point. Classify the points according to center-based density allows us to classify a point based on a core point or a border point or a noise background point. This graph illustrates the concepts. So the cluster can be based on the core point, border point, or the noise point. dbScan starts with labeling all points as a core, border, or noise points. Any two core points that are close enough, for example, within a specified radius distance, will put in the same cluster. Similarly, any border point that is close enough to a core point is put in the same cluster. Noise points are discarded. Here is a graph to illustrate how the points are assigned to the core, border, and noise points. So based on the predefined radius, which is 10 in this case, we can see clearly the separation of the points. dbScan uses a density-based definition of the cluster. It is relatively resistant to noise and can handle clusters with different shapes and sizes. So density dbScan can find many clusters that could not be found using k-means. However, dbScan has troubles with high-dimensional data because the density is more difficult to define for such data. Also, dbScan is now good at handling the data with widely varying densities. And also, dbScan can be expensive, especially when dealing with the high-dimensional data. So I hope you get an understanding of the basic idea how clustering algorithm works from this video. Thank you for watching. Hello everyone, this is Kelly. Welcome back. Let's continue our discussion about cluster analysis. We have discussed some basic concepts and algorithms of clustering. Understand how they work. Now, let's talk about how to evaluate the performance of the clustering models. How do we know the clusters presented here is valid based on different algorithms, including k-means, dbScan, complete link, which is a type of hierarchical clustering. Also, which algorithm provides more accurate cluster? The evaluation measures of cluster validity normally classified into three types. The first one is external index, also known as supervised measures. The information used is not part of the dataset. Clustering structure discovered by a clustering algorithm is matched with some external structure. An example of external index is entropy value, which measure how well cluster labels match externally supplied class labels. The second measure is called internal index, also known as unsupervised measure. It measures how good a cluster structure without respect to external information. A common example is the SSE, sum of a squared error. Internal index is usually divided into two classes, cluster cohesion and cluster separation. We will discuss more about these two measures in the next slide. The third measure is called relative index, which compares different clusterings or clusters. It could be used external or internal index. The purpose of this measure is for comparison. For example, two k-means clusterings can be compared using either the SSE or entropy. The indices are referred as a different name, sometimes called criteria. To be consistent in this class, we call them indexed. As mentioned earlier, internal measures is usually divided into two classes, cluster cohesion and cluster separation. Cluster cohesion measures how closely related the objects in a cluster are. It is about the compactness and tightness of the objects. Cluster separation measures how distinct or well separated a cluster is from other clusters. It's about isolation of the objects. The formula for each measure is listed here. So use SSE as an example. Cohesion is measured by the within cluster SSE. Separation is measured by between cluster SSE. Huijue coefficient is a very popular measure, combines both cohesion and separation. If you are interested to know how to compute the Huijue coefficient for an individual point, you can follow the 3 steps listed here. First is to calculate the average distance to all other objects in its cluster. The second step is to find the minimum of the average distance to all other objects in all clusters. Then the third step is to calculate the Huijue coefficient for a point. Follow the formula listed here. The value of the Huijue coefficient can vary between -1 and +1. A negative value is undesirable. We want the value to be positive and to be as close to 0 as possible. The Huijue coefficient value for a cluster can be based on the average Huijue coefficients of the points belonging to that cluster. There are also some other unsupervised or internal measures, such as measure the correlation among the objects. So the ideal cluster would be the one whose points have a similarity of 1 to all points in that cluster and have a similarity of 0 to all other points in other clusters. In this case, the cluster on the left with a correlation equals 0.9235 is much better than the figure showing on the right. So if we sort the rows and columns of the similarity matrix, all the points that in the same class are grouped together. So this is also known as the block diagonal structure, as shown on the right in this slides. So in this graph, the cluster are well separated, and the red block, which close to 1, means that high correlation among the points, and that represent the points belongs to the same cluster or close to each other. As we mentioned in prior slides, SSE is mostly used in the internal measure to assess how good a clustering is structured without considering external information. So we only use it to compare the performance of 2 clusters and to estimate the number of clusters. For example, the graph shown here on the left, you can see the clusters are clearly separated. And on the right, the SSE for 10 clusters is very similar to 30 clusters. So in this case, it makes sense to use 10 rather than 30. Clustering is a very useful tool for auditors to identify peer groups, detect outliers or exceptions during substantive testing. It can also be used to prioritize the exceptions to determine the appropriate additional testing. Auditors can also utilize a targeted approach to address the specific risks to each cluster. Direct auditors to prioritize their work, and the targeted approach allows for more appropriate and efficient auditing testing. Clustering looks at the data first, then addresses or analyzes the risks on the back end. So this technique is data-driven. It would help remove auditors' biases. So I hope you gain a basic understanding of how clustering works and are ready to perform your own cluster analysis. Thank you for watching this video. Hello everyone, this is Kelly Duan. Welcome back. Let's continue our discussion about cluster analysis. In this video, I will discuss some of the tools that we can use to perform cluster analysis. The first tool I'm going to use is Tableau. You can follow this link here to download the Tableau software. And for students, you can download the software for free. Once you open Tableau, now let's start working on a cluster analysis task. Once we open Tableau, we can upload the dataset to Tableau. In this case, my dataset is related to sales order. I have a sales order number and sales amount, as well as the quantity ordered and the discount amount. So once we load the dataset to Tableau, let's start working on this problem. So in this case, I wanted to generate a cluster based on the sales amount as well as the discount amount. Then I want to group the data points based on the sales order number. Then we can change the shape of those points. Let's choose a circle. So now on the left hand side here, on top, it says data and analytics. If you click on analytics, you find a cluster and you want to drag that to create clusters, this field. So now you have a different clusters is formed. And on the right hand side here, you can change the number of clusters as well. So currently it has 2 clusters, which is orange and blue. Now we can do 3 different clusters. Now you have orange, blue, and red. We can add more, let's say 5 clusters. So we have orange, blue, red, and this color, and the green, etc. So let's say if we do 10 clusters, there are more different colors coming out. So in this case, there's some points are far away from majority of the point. If you think this point, for example, is an outlier, so I can just circle this point, and then you right click on your mouse and select exclude. And you can also do multiple points. For example, this one, this 3 out here, I can select all 3. Then I do right click on it and click on exclude. So your cluster features, the points that are showing on your cluster analysis will exclude those points because they are considered as outliers. So this is a very simple way to do cluster analysis by using Tableau. So now I want to show you how to use Weka to perform cluster analysis. So you can download Weka from this website. It's publicly available and you can download for free. And once you get onto this website, you can click on download and then choose the appropriate version of Weka to download. And for MacBook users, once you download Weka, then you want to go to System Preferences, and under Security and Privacy, on the bottom of the screen, you will see a message like this. Then you want to click on Open Anyway. Then you can run Weka on your computer. So once you open Weka, a window like this will pop up. Then what you want to do is click on Explorer. A window like this will pop up. So now we're ready to do some cluster analysis by using Weka. Once you have a Weka Explorer open, we need to import a data set. So click on Open File. Then in this case, I have a CSV file. Then select the data set, then open the file. Once you import a data set, then you go to the tab under Cluster. And under the cluster here, you'll be able to choose the different algorithms. In this case, we're going to choose dbScan. After that, if you click on this area, so it has a basic explanation about dbScan. And in this case, we wanted to change some parameters for the readings. We're going to do maybe 0.01. And minimum points, let's do 4 points. Then you click on OK. In this case, we wanted to select some attributes that we want to ignore. So if you click on one of those items here, then you click on Shift and the down arrow. You can select different attributes here. And if you have if you have a Windows computer, you can do control, press control and click on one of the items. But if you have a MacBook computer, you want to press a command, then in this case, we want to keep the sales amount and the discount amount. So those are the two items that we wanted to perform a cluster analysis. So in this case, we want to keep them, and wherever the items that highlighted, that are the ignored attributes. After that, you click on select, then we can click on start. So here is the results from DBScan, and we have about almost 5,000 instances in this data set. So based on the DBScan's results, each single points are clustered here, and we have here's the parameters that we just defined. So let's see. And on the bottom of the results, it will show you the clustered instances, etc. here. You can also right-click on this name, it says DBScan. If you right-click on your mouse, it says Visualize Cluster Assignments. If you click on that, then what you want to do is to select what's your X. In this case, you want to do the sales amount. And your Y would be your discount amount. So here's your clustering visualization here. And on the bottom here, it shows different, it's color coded, it has different clusters. There's the blue, red, green, and different colors are listed here. All right, so now we can use a different algorithm here. Let's try the k-means, simple k-means. And if you click on this area, so you can change your parameters here. In this case, we want to do different clusters. Let's say if we want to do 3 clusters, then if you click on OK, and we want to make sure the attributes that we select is still the same, then we can perform the analysis. Then in this case, we did k-means, then we have 3 clusters, and here's the distribution of each cluster. Now you can also visualize this. If you right-click on the simple k-means, you click on the Visualize Cluster Assignment. Then you can choose, let's say, sales amount, which is X, and Y is the discount amount. So here's your 3 clusters. You have blue, red, and green. You can see the distribution of each clusters here. So that's it for this video. In this video, I showed you how to do cluster analysis by using Tableau and VECA. So now I hope you can apply this method in your project. Thank you for watching.